Hi, this is day 19 of the Common Lisp series, and today we are going to continue to look at our grep. So today I want to just show you a few optimizations that I did, but the thing here is they didn't really work, they didn't really help, right? So we'll go into that aspect in the next video, but for this video we'll just look at one core thing, which is the mmap based mechanism to read files in grep. So what I mean by that is, if you take the cl grep example, this is the running example I've been doing. So I just basically time it. So with this I can tell you that it's taking around 53 milliseconds, and my idea was that I wanted to compare this against the performance foolishly against ripgrep. Now if you see here, actually ripgrep has taken longer to do this, but I think that's just because it's run the first time. So if you run this again, you see that it's actually quite fast. So let me just run this a few times. You see it's stabilizing to around 25 milliseconds, but when I run our CL grep, it takes anywhere between 65 to 60 to 75 milliseconds. So in my mind, the thought was, maybe the reason for the speed difference is one, of course, that we are not really going into efficient regex engines for matching. But that said, we are also not doing real regex, right? We are only doing simple string comparison. So our grep is more of a toy. It's not like the real grep. We don't actually have the regex part of it. But even then, while designing this, I had this thought that maybe we should try to speed this up. What can I do? And the one of the things that I wanted to do was the mmap based file reading. So basically the idea is to not read files directly from disk, but to mmap a file, memory map it, and then read the file chunk by chunk from already loaded from memory. So this is our code. If I go back to the core file, and you'll see here in a grep file, basically with one of the CLA flags, I can control between disk and the other option, which is memory. And if you see the core function, it looks exactly the same, but instead of grep file disk, we do grep file memory, right? And you see the two functions here. Actually, like I put in a to do here, there is a lot of duplicated functionality here. I should be able to convert this into use a macro or something to simplify this, but let's not worry about that. Let's just look at the main difference between these two functions. So we have here a read line. So we are saying we'll read one line from the stream, and then we do our match on it, right? And here, instead of that one read line, we have a fetch line, and before that we have this setup where we are initializing this memory map file. So the idea is to memory map this file first, and then fetch lines from that file, and I'll show you the code of that line of what this fetch line is doing. But this is the code difference. And that's the only difference, right? Here we are going to open a file with open file stream file, and in this case it's going to come from the disk. But of course, if there are operating system improvements and caching and stuff, it will also probably come from memory after it's loaded. Once the page is loaded in, and so now the thing is, spoiler, it didn't work. I didn't really get improved performance the way I thought. So it kind of makes this whole thing redundant, and it's a lot of complexity, but still I did it. So I just wanted to show you what I've done here. So here, instead of opening the file, we have this init m file. I'll show you how this function is. And in the end, we have this end m file. And in the middle, we are just going to fetch line by line from this. Now, how did I do this? So I have my code here in this mmap.lisp. But before I go there, I should show you the package that is this mmap package. So let me open the package. This is also yet another package from Shinmira, and this package is basically providing a map in a portable way, basically wrapping the underlying syscalls or whatever is needed on different systems. And basically it's giving you these simple functions, mmap, munmap, and so on and so forth. Now we see the mmap file. I can open the mmap.lisp, and I'll show you what is going on in this file. When you do the init m file, so that's where I'm basically doing the mmap mmap function. So this is where we're actually calling this function that you see here, and there's a bunch of flags that you need to pass, like the way you want a map and so on. And what I'm doing is I'm basically taking all the return value that we get, which is essentially the pointer, the file descriptor, and the size of that mmap file, and I'm showing this in a structure here, which I'm calling m5. Now, in an initial version, I did this and then I kind of just read that file memory line by line. But in some kind of misguided search for efficiency, I thought it would be more efficient to actually read chunks at a time and then process them into lines. So I vaguely recall remembering this is what Grep does. Of course, they do that at the regex search level, right? So they actually do the regex search across a chunk and not within a single line. So I know this as an optimization they do, but of course we're not there yet. I'm doing a simpler thing. I'm just reading a chunk and then I'm splitting it line by line, and then I'm doing the search within a line. All right. So the bulk of the code here is then about how we fetch lines, right? So if you see, there's a lot of things going on here. So I'll just quickly show you. When we fetch a line, basically we will uh, pull data from the file and then take lines out of the buffer. So the way I've done this is, because when you fetch a line, you're actually going to fetch a chunk and that will have more than one line. So you want to actually, get stuff from the file into your kind of working space, where you're already splitting them by the \n and, converting that into lines. And then you just return the lines on their own. So essentially what I'm saying is, we will loop if the buffer is empty. So if it's not empty, that means we just take the top of the buffer and we'll return the value. And then the next time this file, if this function is called, if there is already an item in the buffer, it is just going to keep returning it. All right. And when you're done, this is how we mmap. We need all of these arguments. That's why we're storing that in the structure. We call mmap. If you see here, the name and these working variables are just meant for the mmap and the unmap part, but these last three variables are what is more important, which is about the buffer and how we're managing the chunks, right? So the offset is basically how far you are into the file. So basically you need to read a chunk from the offset and then you store the data as lines in buffer, and I'll talk in a minute about what is extra variable is to it. So our core thing is update buffer, and so what we're saying is that we are going to actually, this is where we actually read from the file, and you see here this logic, some calculation going on here, managing the offset, the chunk size, especially for the last chunk, right? So when you're towards the end, you can't really take the whole thing. So that's why we have size. The size, this is the size of the full file. And if you are actually reaching the very end of it, then we just need to take that last chunk would be lesser than the chunk size, right? So that this logic is for that. This is the number of bytes that we want to read. And the interesting part is this actual thing, right? How are we reading the data? And we are reading this data with this cffi function, foreign string to Lisp. And this is where we are actually passing the pointer. And if you see here, this is not the pointer to the starting of the file. This is the pointer by incrementing the start of the file location with the offset that we want to actually read. And now with this pointer, we want to like take that many bytes. So essentially the number of bytes that we want to read, normally it's a chunk size, and we want to read that data as a string from that pointer. So the rest of it is the logic that follows here is how we manage the chunks and the lines at the end of the chunks. So you see there is this bit of complicated code here. So what it's doing is that within the chunk, it is like 4000 bytes. Now there are multiple lines in that, but the last line, right? So that last line probably gets split between this chunk and the next chunk, and that's where this extra variable is coming in. So basically, I'm just storing the last portion into that extra, and then when the next chunk is being read, I'm taking the first part and then I'm concatenating that with whatever was stored in the extra from the previous batch. So there's a bunch of complicated code here. By the way, I'll tell you again, I did this and I ran it and it does not give me any performance improvement. So if you want to see it, like I said, there is a flag. So I can simply go to CL grep and I can change from the disk mode to the memory mode, and you see that there is no improvement. It's at the same ballpark. And I can also change the chunk size. There's a flag that I put in. I don't remember what that is now. Let me quickly look that up. So when we added the options, you will recall that there was a chunk size, and this is the chunk size. So that's dash C. So that's the flag we have set here. So I can basically set that to say 8,000, right? And there is almost marginal or no improvements. And I've tried for different folder paths, and uh, I can tell you one thing, that if I reduce this down to like 50 bytes, you will see that there is significant slowdown, because now we are reading chunks which are actually lesser than a single line, right? So you see that it's actually slower. So you see the impact of this flag, but there is no good number, right? I'm not able to, if I set the default, which is like 4,000 bytes, the performance is like okay, but not doesn't really improve beyond this. So if I make this 20,000, it doesn't really improve. It's the same ballpark. So with that aside, the fact that it didn't actually work, I just want to focus on the logic here. So we have basically done an mmap, which is a standard lower level system kind of operation. Those kind of things are very easy to do in C. I mean, if we just go and do man mmap, you will get documentation about all of this, right? Like what are the functions, what are the pointers, and how does it work, and so on. So all of this is low level system programming, which is very easy to do in languages like C. I mean, you see all of these flags, like we want to share those pages, and all of these aspects. Now, getting this level of access in Common Lisp, that can be a bit of a challenge. So that's what I wanted to just show off today. So in this library also, for instance, there is this POSIX.lisp is the implementation of, and you will see that to do this implementation, we are heavily relying on this library called CFFI, which is C foreign function interface. And you see we're defining all the flags and the bit fields and so on. So this is how the library has been built. And there is also, you can see that when you call this is called like a map, you're going to get pointers back. So we need to actually wrap that and enable access to that from Common Lisp. So that becomes the like actual challenge. You see there is more the exact way this works. I mean, this is not important for us, but if you see this example, and if you see the I believe there's an example somewhere here, maybe this one. Yeah, so if you see the example, you will see this, or they're using a map the way we have done it. But the important thing to focus on here is this reading the string from the pointer. So this is not a function that is coming from the map library, it's coming from the actual core CFFI library. So knowing that is basically needed if you want to do that level of system program. Now there is a lot more to actually using CFFI. We'll have a full video about this later, but for the moment there is a small example in the Common Lisp book about the def C function. So it's talking about how to define basically the Common Lisp wrapper over the C inbuilt functions like C. So it's talking about what's the argument, what's the return value, and so on, and then that gets expanded to something like this, where there is going to be a foreign call to the actual C library with it. And now the actual reference is quite complicated. There's a lot of things going on. CFFI, this page is also nice. It's talking about limitations, various aspects, and giving an example about how to actually do this. Now we will go through detail about CFFI later. We'll wrap some C library and we'll use it, but for the moment, we will not go into this. So to summarize, what we have done here is basically used the CFFI and the mmap library, which is a wrapper on top of the platform specifics to be able to actually mmap files and read the data from the pointer using like a chunk mechanism instead of just like reading lines. Now, in this case, that didn't really help me, but this is the kind of low level system programming that you can do even while you're in Common Lisp. Now in the next video, I will talk in detail about what I should have done, right? And what is the right way to go about timing and examining, profiling, tracing your program. If you're interested in basically looking at where the performance is coming from or where it's not coming. See you there. Bye.